Hi, this is a tutorial series to teach you how to make your first game in GameMaker in 3 simple steps. My name is Dr. Sky, and I'm a professor of digital media arts at the University of St. Thomas in beautiful St. Paul, Minnesota. This is step 2, and in this video you'll learn about adding a score system, sounds, and keyboard controls to your game. Last time when we were working on this project, we had some basic game mechanics implemented, and the game more or less looked like this. We had instructions that pulsed, and we have this game mechanic where when we hover over these blocks, they disappear, and if a block reaches to the top of the screen, the game restarts. And you can see that happen right here. Now let's keep adding to our game by adding a score system. So first we're going to open rooms and go to our title where we declare our global variables in the creation code. And after global.blockSpeed, we will add the global variable global.points equals 0, semicolon. Now, exit out of that, center fit that room, and exit out of the room editor. And now create a new object, create object, and let's call this score. And let's add a draw event. And write a comment, black background, draw set color, C black, draw rectangle. And with draw rectangle, it's a function where we can draw a rectangle. The first 2 coordinates are the top left corner, the second 2 coordinates are the bottom right corner. And then the last argument is whether we want this to be an outline or not, and we don't. So the coordinates that I want to do is 0 and 0, meaning we're going to start the rectangle in the very top left corner of our game room. And then we want it to be 60 pixels, 60 pixels from the right, and 40 pixels from the top for our bottom right corner. And we want this to say false or 0, meaning we want this to be a filled in black rectangle. New comment, because we want to do another rectangle that's just an outline, similar to our instructions. Comment aqua outline to background. Oh, no comment lines there. Draw set color, C aqua, semicolon. Draw rectangle, 0, 0, 60, 40, and we'll set this to 1 or true. I choose to use 1. Another comment, display points. Draw set font. Let's do the same font as our instructions, F instruct. Draw set color, C white. Draw set H align, far left. Draw set V align, far middle. Oh, let's do actually far top. We want it to be top, draw it from the top. A little easier when you're doing something in the top right corner to set the vertical alignment to the top. And then draw text. And we want this to draw the text wherever the object is placed. So that's why we will say X and Y for its X and Y coordinates. And then a new function. Normally what we would do here is write some text here for it to display. But since we want it to take the global, the points for our point value, we would want to write global.points. However, this doesn't work because global.points is an integer number value, and this function requires a string to be its third argument here. But we can convert this number into a string version of the number, so it's no longer 3, but instead it'll be like 3 or 0 or 10 or whatever, by simply using the following function. The function is called string. String, open parentheses, global dot, I can spell global dot points, close parentheses. So you should have double close parentheses here. And that way it'll convert whatever our points are into a string of text that can be displayed. And now we're going to add a create event and write a comment, location of score. Let's say X equals 8, Y equals 5. Now we could figure that we could move it around manually in our room, but sometimes I like to set an object's position in code so we can tweak it more finely. And then we're going to open our game room. Our game And under the instances layer, we're going to take oscore and drag it in. Now, it doesn't matter where we drag it because the instructions in the creation code will put it automatically over in the top left corner, but I'll put it over here generally just so I know where it is. Exit out of that and let's run the game and see what it looks like. So we should see a 0. 0 here, and then that little rectangle. Now, destroying blocks doesn't increase our score yet because we haven't added that code, so let's do that next. Exit out of this. In our O block object in the step event, we're going to add the following code to where the object gets destroyed by the mouse. So right here where it says instance destroy, right before it destroys this block, we will write global.points plus equals 1. And because this line of code will run only once, because it's the code that destroys the object, we don't have to worry about our points going up a bunch every single frame. If we wrote this somewhere else in the step event, like up here, the score would be increasing every frame of the game. In fact, if you want to see what that looks like, you can run it here, and it just increases more and more as more blocks get in there. Let's delete that. Fun little experiment. But we put it here so that every time we touch a block, it'll increase our points by 1 point. So every time I touch a block, it increases the score by 1, and it displays it appropriately. Now let's add an explosion to the block so we get some better graphics. So in this step, we're going to add something when the blocks disappear. We're going to create a new sprite. So let's exit out of this. Hover over sprites, right click, hover over create, and select sprite. Let's rename it S-Bits. S-B-I-T-S. Change the canvas size, resize canvas to, let's say, 10 by 10. Hit apply, hit edit image, fill tool, and let's fill it with a bright red color. And set the origin to be middle center as well. Now we're going to create an object, right click objects, create object, and call this O-Bits. Assign its sprite. And we're going to add a create event and write a comment, set speed to, let's say just set speed. Speed equals 6. Let's add a step event. Fade out. Oh, we need a comment line here. Double backslash. Fade out. Now, condition statement. If image alpha, this is a built-in variable, a built-in property of objects. And what this is how transparent the sprite is for our assigned object, and we can manipulate it and also check it. So right now it's going to check how transparent it is, and automatically all objects with sprites assigned to them have an image alpha of 1 automatically. So they're very visible. So we'll check, hey, if it is greater than 0, open curly bracket, close curly bracket, we will write image alpha minus equals 0.05. So, hey, if we can see it, if the image alpha is greater than 0, reduce its transparency by 5% every frame of the game. Also, else, meaning, hey, once we get to 0, once we no longer can see the bits, we can destroy them. Instance destroy. Now, we don't have to put instance destroy, I guess, because you won't see them, but it occupies game memory unless we get rid of objects when we don't need them, and so that's important to get rid of objects when we don't need them. Now we're going to create a new object. Create object. Call this one OExplode. And in the create event, let's write this with some copying and pasting. So I'm going to show you the long way to do something and then the short way to do something, because it'll be difficult to understand the second way unless we do it the first way. So I'm going to write bit1 equals instance create layer. And this, remember, this function is used to create new instances of objects in rooms. X, Y, just create it at the same location of wherever OExplode is. So that's why we just put X and Y here. The layer is instances, and the object is obits. And since we've used this function and assigned this function to a variable name, this is a cool little tidbit that you should learn, that if you do this, it will create sort of a temporary name for this instance and assign it this variable. So now we can interact with this one particular instance of this object using this variable name. And we do that with a with statement, with bit1, saying, hey, we want to do the following code that we're about to write inside of this particular instance that is named bit1. Open curly bracket, close curly bracket, direction equals 0. Now remember, we assigned a speed to our obits object of 6, but we didn't give it a direction. We didn't tell it where to point when it starts moving. So what this will do in the create event of oExplode, we'll create this instance, give it a name of this variable, so that we can use a with statement to give this one particular instance a direction of 0. But we want to create several different instances of obits. In fact, we want to create 4. So let's do some copying and pasting. So I'll copy all of this and paste it 3 more times, except call this bit 2, bit 3, bit 4, bit 2, bit 3, bit 4, and then direction 90, 180, 270. And then after the end of it, after we do all this in oExplode and its create event, we are actually going to no longer need this explosion object anymore. So we are going to write instance destroy. So basically, this is a cool object that just comes into existence, creates the obits, and then destroys itself. And now we can close out of this and we can go to oblock. And in the step event, right before it destroys itself after global dot points, we can add instance create layer XY, meaning we just want to create the explosion object exactly where this block object is. Instances explode. So what this will do is that it'll give us our point, it will create our explosion object, and then it'll destroy itself, and then our explosion object in turn will create 4 flying bits that are going to spread in different directions. Then our explosion object will destroy itself, and then our 4 bits will move and fade out, and once they're faded out, they'll destroy themselves. So let's see how that looks. Let's hover over this. See those 4 red dots flying away from our block objects. Now this works, but it's not very elegant. That's a lot of copying and pasting. It's not the best way to do this. So the best way to do this is to use a for loop, and this is a great opportunity to teach you what a for loop is. For loops are great at reducing repetitive code, which if you look at this create event is a lot of repetitive code. That all has to happen in a single frame. And that's what a for loop does. A for loop does something repetitive all in a single frame, and then it's finished. So what it does is that it creates a variable. It then evaluates whether something is true or false. And then if it's true, it runs some code. And then a statement is performed. Some piece of code is run. And this happens all during a single frame. So for example, let me just do this up here. For, open parentheses, I equals 0, we declare a variable. We check for a condition, I is less than 10. Oh, yeah, we have to do semicolons here, I forgot. Semicolon, semicolon. And then something to run after it runs the instructions. I'll just put something temporary there. So declare a variable, check to see if this variable is less than 10 here. And then if it's less than 10, instance create layer X, Y instances obits. And then after it creates obits, it goes back and performs a line of code here, which we can write I plus equals 1. So again, in this for loop, it creates a variable, declares a variable, I guess is the technical term. It then checks to see some sort of condition. So here it checks to see if our variable is less than 10. If it is, it creates an instance of O bits, and then it increases I by 1. So now I equals 1. Is I less than 10? It is. Create O bits. Now it adds 1 to that. So now I equals 2. Is 2 less than 10? It is. Creates O bits. So it sort of gets rid of repetitive code for us. So we can consolidate all this bulky code into a very elegant for loop. And I'll show you how to do it. So first delete everything before instance destroy. We're going to write this above that. We will write for, open parentheses, bit dir, meaning the direction of our flying bit, equals 0. So we just declared a variable. If bit dir, we'll just write bit dir less than 360, bit dir plus equals 90. Open curly bracket, close curly bracket. And now we're going to use a temporary or local variable, and we do that by writing the word var bit. So you're going to see bit turn yellow in a second. And what this is a temporary variable. It's a variable that we only need to use very quickly, and then we can get rid of it out of the game's memory. It's useful in cases like for loops, because we don't need this variable to be remembered after this bit of code is run. Var bit equals, and then once again, we'll create our instance. Instance, create layer, create it exactly wherever oexplode is, xy, in the instances layer. And then the object is obits. And then with bit, that's going to turn yellow too, with this instance of obits, set its direction to equal, this is kind of fun, other dot bit dir. So within a with statement, if you want to reference a variable that is outside of the with statement, you write other dot, and then you can put the name of the variable, which is bit dir up here. You know, now that I think of it, we don't even need this to be like a declared variable. This can also be a temporary variable. I'll write var before that, and it's going to turn that yellow. Maybe that doesn't work for other. Yeah, probably doesn't work. Never mind. I'm still learning. There we go. We'll just keep that declared. All right, so what this will do is it'll declare this variable. It'll check if this variable is less than 360. If it is, it'll create an instance of obits, and then it is going to assign as that bit's direction this number. So it'll set it 0. Now, if you remember with direction 0 is right, then it's going to add 90 to it, and then check again. Bit dir is 90, so 90 is less than 360. It is, so it's going to create another instance of obits and set its direction to be 90. It's going to add 90 more to that. Now it's 180. So it's going to be 0, 90, 180, 270. So it's going to create 4 instances once again for us. So if we run the game, the exact same thing should happen when we hover over our blocks. Exactly. And that is a for loop. Now I know it can be a little confusing. That is totally okay if you don't understand it. I just wanted to introduce it, and if you want to read more about for loops, you can look up the help manual in GameMaker and learn more about them. But just for now, just know that it's a great way to do repetitive code that runs in a single frame. So all of this happens in a single frame. So we can add sounds now to make the game appear more lively. We have some graphics. Now let's add some sounds. We will use sounds that I've made, but if you have sounds that you want to make, feel free to import those as well. We want 2 sounds. We want a sound for when the blocks break apart or explode, and then we also want some background music. So let me minimize these drop down arrows. Now over sounds now, right click, hover over create, and click sound. We're going to call this one SND, and let's call this break, SND break. Now click on these 3 dots to choose our sound. Oh, I need to find those assets. There we go. And SND break, I think I have it called, SND break.wave. And you can hit play here to listen to it. That's our breaking sound. And now we are going to add some code to play this sound in our game. We're going to go to our block object. Hold on. And then right before we destroy our block object, after we create the explosion, we're going to write audio play sound snd break. The next required argument is its priority, and for very simple games, like any of the games that you'll be making, we can set the priority all to just be 1. It's fine. And then whether we want it to loop over and over again, and we're going to write false. We don't want it to loop over and over again. So that's our sound. Now it's important when working with sounds to know that this will play a new instance of the sound every time this code runs, but this code is only happening in 1 frame, so it's only going to play our sound once. Now, if we put this sound up here in the step event, it's going to play this sound 60 times per second, which is horrendous. You don't want to hear that. In fact, maybe you do want to hear it. Let's see how horrible it sounds. Let's run the game. It's horrible. Let's delete that. Instead, we only want it to play when we destroy a block, which happens in 1 frame, which is nice. Let's hover over it. Beautiful. That sounds a little loud, so you can actually double-click, open this asset, and here you have a volume slider. You can actually adjust the sounds directly in GameMaker if you don't want to open up an audio editor and re-export the audio. So we can adjust the sound. I'm going to change it down to like 71% or 70%. It's a little better. And now let's play some, let's create some music. So let's go over sounds, create sound. Let's call this one SND music. Let's import the appropriate file, SND music. And let's open our title room, our title in the creation code. At the very top, let's write some code, comment play music, and the code is if bang, so whatever we're about to write after this is checking if this is not true, if audio is playing. So because we have that bang before it, it's asking, hey, if this audio is not playing, do the following things. And the argument that it needs is a sound ID to check, which is SND music. Double close parentheses, open curly brackets, close curly brackets. So here it's saying, hey, if this audio, if our music is not playing, do this in these instructions. And you can also use this function as if audio is playing, but here we need to check to see if it's not playing. If it's not playing, play it. Audio, play sound. SND music, priority of 1, and we do want it to loop, so we will write true there. We do that right here at the beginning of our game. Let's run the game and see if we hear it. We do. Close out of that. Oh, center fit. Close out of our title. All right. Let's make an object we can control with the keyboard instead of using our mouse. Mouse control is fine, but it's a little inelegant, and this is a great opportunity for you how to do keyboard controls in your game. Say if you want to make a platformer game and you want to have buttons control what a character does or something. So let's learn about keyboard controls. First, let's create a new sprite. Create sprite. Call it S terminal. Click import and import all 4 of these images called terminal. And set the frames per second to be 4 frames per second, its origin to be middle center. And you can click play to see what the animation looks like. Now we're going to create a new object. Call it O terminal. Assign the appropriate sprite. And in its step event, add event, step event. Write a new comment, get inputs for key variables. Key right equals keyboard check. Keyboard check is a great function. It checks if a key is being held down. And then we put in the argument for which key to check, which we're just going to use the arrow keys. And for here, we write vk underscore right, the right arrow key. Key left equals, put a minus or a subtraction symbol there, minus keyboard check vk left. Now, I'm going to explain why we put a subtract here in a moment, but basically whatever we want to make this value negative. I'll explain why in a moment. Key down equals keyboard check vk down, and then key up equals, again, subtract or negative keyboard check vk up. New comment. Calculate horizontal and vertical movement direction. H move. Now there's going to be these cautions appearing because we haven't declared these variables yet, but we're going to declare them afterwards, after we write this code. H move equals key right plus key left, semicolon. I'm going to add a comment after -1, 0, or 1. And then v underscore move equals key down plus key up. -1, 0, or 1. All right, so let me explain why I added the negatives here. So keyboard check will return a 1 or a 0, depending on whether this key is being pressed down. If our right arrow key is being pressed down, this will turn into a 1, and key right will be assigned the value of 1. If it's not being currently pressed down, it will return 0, and key right will be assigned 0. Now, the reason we want this negative is, if you recall in our rooms, moving right increases the horizontal or x position or x value, and moving left decreases it. And with up and down increases the value and up decreases the value. So what we're going to do is we're going to create a new variable called hmove, horizontal movement, and then add these two values together so that if the key right is being pressed, it will return 1, and if key left is not being pressed, it will return 0, so 1 plus 0 is 1, so hmove will be assigned 1, and 1 means go right. If key left is being pressed, that's -1. Key right is not being pressed, that'll return 0. So 0 plus -1, hmove will be assigned -1. -1 will mean go left. If both keys are being pressed, 1 plus -1, it will return 0, which means don't move. Or if neither of the keys are being pressed, 0 plus 0, it will return 0. It means don't move. Kind of an elegant solution, meaning if you're pressing down both right and left keys, nothing will happen. If you're not pressing either key, nothing will happen. If you're pressing just one, it'll move either left or right. Same thing with vertical movement. Another line, another comment. How fast and in what direction? HSP here for horizontal speed, but we don't write H speed because that is a built-in property in GameMaker. We'll write HSP, shortened version of that, equals hmove times move speed. So we'll take this value of -1, 0, or 1 and then multiply it against how fast we want it to be moving. If this is 0, 0 times anything will make it 0, so it won't move. If it's -1, it'll make our move speed negative, which will move our object to the left. If it's positive 1 times our move speed will make it positive, and it will move to the right. Same with VSP, or vertical speed. VSP equals vmove times move speed. And then lastly, new comment, do it. Change this object's X and Y positions. X plus equals HSP, Y plus equals VSP. And now we need to declare all these variables in a create event. So go to create, and let's declare all these variables. Key right equals 0. Key left equals 0. Key down equals 0. key up equals 0. HMove equals 0. VMove equals 0. HSP equals 0. VSP equals 0. Move speed equals, now we can decide how fast we want it to move. I'm going to set it to 4. Now we have this object, but it hasn't been added to our game yet. So let's open our game room. Make sure the instances layer is selected. We're going to drag and drop this terminal in. I'm going to put it kind of center closer to the bottom and run our game. Now when I use the arrow keys, it should move around. When I press down both at the same time, it stops moving. If I can go up and down, if I press down both up and down, it stops it. And I can move diagonally nicely. Now what we're going to do, we're going to make it so this terminal object is the thing that destroys the blocks instead of the mouse. So let's close. Oh, we don't need to close this. This is where we need to be. In our OBlock step event, we're going to change this condition from if distance to point mouse X, mouse Y is less than or equal to 0. We're going to change it to a different function. So if, open parentheses, place underscore meeting, a new function. This checks to see if two things are overlapping or if two things are in the same location. Place meeting, X, Y, O, terminal. Double close parentheses because we have two open parentheses. So this will check to see if our block object overlaps at all with the terminal, O terminal object. And if it overlaps at all, even by 1 pixel, it will increase our points by 1 and do all of this thing all in a single frame. It'll destroy our block object. Let's run the game, see if it works. It does. So the mouse no longer is the thing that destroys the blocks. In our instruct object, we need to change the instructions a little bit. Let's go to the draw event where we give our instructions, and we're going to write for our first set of instructions, use the arrow keys to move and break the blocks. Exclamation point, make it a little bit more urgent. So now we want the block explosions to be on top of the terminal object, and this is a good opportunity to teach you about different layers in rooms. So to decide what objects appear on top of what other objects in a room, we're going to create different layers in a room where the topmost layers appear on top. So in our game room, our game, we're going to click this button, which is create a new instance layer. This is where new instances can be. You can see we already have one called instances, and we're going to click this and rename it to top layer. And we're going to rename this instances layer. You can right click and click rename, or you can just highlight it and hit F2. We'll rename it bottom layer. Now, this is a good opportunity to show you what happens when you make a mistake in GameMaker, what happens when GameMaker gives you an error code. Let's just run the game. Now, our game should not work because we've changed some important things. See, it already gave us an error in our control object, because in our control object in an alarm 0 event, it's telling it to create a block in the instances layer, but we no longer have an instances layer. It gave you all this information, so now you know to go to oControl alarm 0 and change this to a layer that exists, which we're going to say bottom layer. Now you can go and just find the errors for each time you need to change something like this, but I can just tell you where to find them. We're first going to open our game, and we are going to, in our bottom layer, select bottom layer and select the instructions, the control object. Let's see, what's this? This is our instruction object, our control object, and our score object, and we're going to delete them. We're going to click top layer and move them all there. So oControl, drag that in, oInstruct, drag that in, oScore, drag that in. And we need to change something here. Let's see. We need to go to, I believe, let's see, O blocks. Yeah, O block, and we need to change this where it says instances and change this to bottom layer. And see where else. Let's find out. Let's play our game and see where else we need to change the name. Oh, there we go. Oh, explode. There we go. Oh, explode. Create. Yep, here we are. Bottom layer. Got to spell it correctly. There we go. Everything's working appropriately now. It's important to get comfortable with error messages and seeing what the error message says to tell you what to fix. All right, we've added sounds, we added keyboard controls. That's it for a relatively short video. In the last step in this tutorial series, in step 3, we're going to learn about collisions, which means how we stop objects from moving when they touch other objects like walls, and also how to add room transitions that fade in and fade out, move us between areas or different rooms. So I will see you there.